Okay, so we had, I just went back through it to make sure we got all of our data points. Sorry about that. So here we have it. The normal rat consumed much more oxygen, which would indicate that your BMR, of course, is higher. Now, what's important to notice here that without a thyroid and without a pituitary gland, it is lower. The amount of oxygen you consume in a minute is lower. The BMR, which is of course your basal metabolic rate, is lower. However, there is no mass. There's no palpations. Okay, so we're ready to move on to the next one. So let's look at some of these. Judging from the basal metabolic rate, an indicator of thyroid function, categorize the rats as hypothyroid, which is low in levels, BMRs of below 1600. Thyroid, U just means good, new, normal. Thyroid levels, which is 1650 to 1750, or hyperthyroid, which means above or higher, which is above 18. So for the normal rat, of course, it's 1710, which is a normal range. So we're just going to say normal. You could check your answers, but I guess you do. So I'm going to submit it. The thyroid is below 1600, which was our hypo. So I'm going to put hypo. We're going to check it. Yep. And then of course our one without a pituitary gland is also in the 1500s, which would be considered hypo. So I'm going to check the answer and submit. Okay, so what do you think would happen after you inject thyroxine into the 3 rats? So thyroxine is T3 that is created by the thyroid, and T3 does increase the metabolic rate. So hopefully, let's see if we can make it. So a normal rat will become hyper thoracic and develop a goiter. That's possible. Let's read through all of our options. The thyroidectomized rat will become hyperthyroidic and develop a goiter. Probably not, because it already doesn't have a thyroid. The hypophysectomized rat will become hyperthyroidic and develop a goiter. Probably not again, because those would be increasing thyroid anyway. The normal rat will become hypothyroid but not develop a goiter. I'm going to guess this one right here. I'm going to submit my answer. Okay, so let's do our next series of reactions. So drag the syringe filled with thyroxine to the normal rat's hindquarters. Release the syringe to inject the thyroxine into the rat. In this experiment, the effects of the injection are immediate. In a wet lab, you would have the injection in the rat daily. Okay, so it looks like we leave the rat here. Let me see if this will let me. Is that what I needed to do? Drag the syringe. Sorry, I'm up here. So I'm going to drag this syringe. With thyroxine in it. So we're dragging this one and we're going boop. Ooh, look at that. Okay, so we drag the syringe. In the wet lab, you would have to inject the actual rat daily for like 2 weeks. So the real thing. All right, so we're going to push next. For this part of the activity, follow the same procedures as 1 through 4, dragging the rats in the chamber, weighing them, doing the clamp, following all those same things, then select inject to equalize. Okay, so same procedure. Wonderful. I've got it down now to an art form. So I'm going to weigh the rat. I'm going to turn the clamp on. I'm going to give it a minute. Oops. Give it a minute. We're going to start that. Again, it's preparing us for our calculation, so it wants us to do the steps on our own. Okay, so it has been, and then I'm going to turn this one on, and then I'm going to turn that one off. And let's see, it has been averaging in the 6s, so let's start there. That looks about, so let's start at 6. And we'll inject. It looks like it's going to be a little bit more than that, which is to be expected. Your metabolic rate increase, so would your need for oxygen increase. So let's go ahead and get that here and see a little bit more. So yeah, we can already tell that we've increased our rate of oxygen consumption. Okay, so it leveled out at 8.3. So remember what we do is we take that 8.3, and I'm doing this off screen because why wouldn't I, right? So 8.3, and we're going to divide it by 60, which is how we convert. Of course, this, that can be set up in one of those T-chart things. But this value is 0.138333333, and so forth and so on. And then, of course, I take that value and I divide it by the weight in kilograms, which remember our weight in kilograms was 0.249 for the normal rat. Excuse me. So this becomes pretty much that. We're submitting. We're going to palpate our little rat. No findings. We're going to record our data. And then it says drag the rat from the chamber back to its cage. Okay. And then select clean to clean the area of all thyroxine. Okay, so again, that would take weeks to do in real life is what they're implying. Okay, so let's do this with all of the rats. So we're pulling the rat over, we're getting a weight, we're turning this on, we're taking this to a minute. And I might do this off screen and get all of our, most of y'all can kind of get the procedure. So I'm going to pause this. I'm going to do the rest off screen to make our video a little shorter and then come back and talk about our table. Okay, so I'm coming back after having done the thyroxine. You can see here injected 3 times. So compared to the normal rat was 7.1 originally with no added hormone, BMR of 1710. Well, with thyroxine, it went to 8.3 consumption to 2000 BMR. Look at the rat with no thyroid, 1536 to 1926, which is actually a hyper situation. And of course, the no pituitary went from 1542 to 1885. Interestingly, no masses yet. So no goiter resulting from the increase of thyroxine. Okay. So I am going to go through these again. And all 3 of those were above 1750. So we're going to say hyper for all of those. And then we're going to move on to the next injection. So which of the rats developed a goiter? So none of them. And we move forward. Okay, so what do we predict will happen after TSH? Okay, so the normal rat will become hyperthyroidic and develop a goiter. That's possible again. It's basically the same thing. The one without the thyroid becomes hyper. The injection will have no effect on the rat with no pituitary, therefore it will not develop a goiter. The normal rat will become. I'm just gonna keep going with this one. Honestly, it's okay. So I'm gonna do the same thing, but this time I'm gonna add TSH, which is thyroid stimulating hormone. That hormone comes from the pituitary versus the thyroxine that comes from the thyroid. So I'm gonna pause, do this set, and then come back and talk about the lab. Okay, so I'm back after having done this set of experiments. So here is our THS, which is thyroid stimulating. Interestingly, which finally my goiter appears, that's our mass, and it happened to the normal rat and the rat that is experiencing a missing pituitary. What you have to remember is just because the pituitary is missing doesn't mean the thyroid isn't already there. So the thyroid rat did not have a mass and he went back to hypo. What happens is no matter how much you try to stimulate the thyroid, if the thyroid is fully missing, then you can't stimulate it. So it can't create a goiter. However, if you have normal rat, of course, you can overstimulate the thyroid to create more materials, increasing your BMR to create a goiter. And also what's interesting, again, it seems a little weird, but this rat that had the pituitary removed, when I added TSH, it kind of acted like the normal rat because the thyroid was normal in there. And so you again have a goiter form. So, very interesting kind of conception there. And of course, if we look at the BMRs, our normal rat and our rat without a pituitary are both hyper, and our missing thyroid rat is hypo. So this one is hyper. This one is hypo, and then this one is hyper. Okay. Which of the rats did not develop a goiter after the injection? Of course, that was the one without a thyroid. Okay, now I'm going to stop the experiment here because I think that for the most part, you're getting the idea. This next series of ones would be a chemical that inhibits the production of thyroxine. So we could go through this again, but I think the ultimate thing that you understand from this activity that I've displayed is that as we manipulate the different hormones, so there are different responses based upon where the hormone is being interrupted at. And so this is kind of the takeaway that your metabolism can alter if there is a change in the thyroid, if there's a change in the pituitary, and so in a combination of all of those, and then thinking about drugs and receiving supplements. And I mean, I as a kid, I received some for I wasn't creating enough T3, so I basically got thyroid stimulating hormone and it turned my thyroid back on. So that's kind of the takeaway, just making sure that we understand that our metabolism is linked to our thyroid, and many other metabolic processes are related to or connected to these endocrine glands, and any change in that hormone level or any change in the presence of the organ can alter your metabolism. All right, thanks. Bye.